Hey, everybody. Welcome to this edition of Shop Talk Live, where we'll be discussing some of the big MIG welding aluminum. I'm Andy Weyenberg, and I work with the aftermarket performance and motorsports industries for Miller Welders. Joining me is Chris Roehl.
Hi, everybody. My name is Chris Roehl. I'm the product manager with Miller Electric. I'm the product manager for the Millermatic products. I've been with Miller for 35 years, and over those 35 years, I've visited a lot of customers, helping them with their aluminum applications. I've talked to a lot of people at shows, so we're looking forward to talking about some of our tips and tricks that we can share with you guys, and also to answer some of the top questions that people always have about MIG welding aluminum.
Yeah,
Also,
and
I'd like to go over to the third person on the team.
Yeah, hi
James.
everybody. My name is James. I'll be kind of the voice in these guys' ear tonight. I'll be the one answering questions in the chat, and if you guys do have any questions, feel free to throw those in the chat. I'll either answer them in the chat for you, or I'll have the guys answer them live on this stream for you.
yeah, and Chris is donning a welding jacket, and he has a machine powered up next to him, so he's going to be even doing some live demos. So yeah, definitely throw your questions in chat, and we'll see if we can accommodate all those. But basically, since this is basic MIG aluminum, let's start out first with the process. And the process is MIG. And typically MIG means it's a constant voltage process. So we're going to be working with your standard MIG machines. You won't believe how many questions I get from people wanting to hook up a spool gun or something, or be able to MIG weld aluminum with a TIG machine, because they're very familiar with TIG welding aluminum. And to them, it's kind of the same in their head. It's just how they're delivering the aluminum, right? Whether it's a wire or whether they're feeding it manually with the TIG process. Well, there are some real expensive interfaces and boxes that you could connect to a TIG machine to kind of make it work. It's not ideal, but by the time you do that, you really could have bought a regular MIG machine. So our process is CV, constant voltage. And a MIG machine, that's what it does. It manages and monitors your voltage. You set voltage on the front of the machine. A constant current machine, it monitors and controls. You set amperage on a TIG machine, or you set amperage on a stick machine. That's how you can really tell the difference. So if you're setting voltage on your machine, chances are it's a constant voltage machine, and you should be able to weld aluminum with it. So why not AC? Well, first and foremost, our basic MIG machines don't even have that capability to MIG weld AC. And AC is really used in the TIG process to assist in the cleaning of the oxides off of the aluminum. So on the electrode positive side of the AC, it helps chip and blow those oxides off. The electrode negative side then welds the aluminum. Well, with a constant voltage machine, we don't have that. And plus, with TIG welding, you're working with a tungsten that is actually transferring the arc energy. With MIG welding, the wire is electrified and is being transferred through the weld puddle. So it would really create an unstable arc condition trying to impose AC when MIG welding aluminum. So for all practical purposes, we're going to be discussing just DC MIG welding with the aluminum. So there are some MIG machines that are also MIG. We'll discuss some of it later. You know, a lot of people say that you need to use a pulse machine, and that's not true. You could use just a standard MIG machine. Pulse is great, and it does offer you some advantages, and we'll discuss some of those later. Technique is really another differentiator between MIG steel and MIG aluminum. On MIG steel, and we'll show you some of the differences on technique as well. But the big thing with MIG welding aluminum is you're going to be pushing the weld puddle instead of dragging, whereas in steel, you could go either way. So that's probably the biggest technique. We'll also talk about your contact to work distances, and we'll talk about some joint designs too. So really, the MIG welding aluminum is better suited for your standard fillet welds, like a T-joint, if you would, a lap joint, or just a regular butt joint, or a flat weld. Not so good for your outside corner welds. Unless you're working with some much thicker materials, the outside corner welds are are quite a challenge with spool or with MIG welding aluminum. So we're going to talk about the different filler metals that are ideal for the situation. And we're also going to talk about some of the like troubleshooting, like why is my welds black and some of those too. So Chris, why don't you tell us a little bit about what MIG guns are properly used?
Right, exactly. Also, before getting into that, also the other thing when you're welding with aluminum, MIG welding aluminum, you need to use 100% argon. You know, typically when you're welding steel, you're using a 75-25 mix or 100% CO2. The one thing you definitely need to do is, you know, switch it over to 100% argon. So, you know, that is the other thing that you need to do for, you know, the MIG welding application. So,
Yep, absolutely. Yeah,
so
and the biggest reason is, you know, like people think that just because it's MIG welding, they're so used to, again, it's the process. I'm MIG welding, it's 75-25. If I'm TIG welding, it's argon. But it's not true. It's also material specific. So aluminum has to be used with argon, and it is an inert gas, which means it really doesn't react or respond to anything that like your arc energy, or it doesn't respond to electricity. It's strictly a shielding gas. Whereas CO2 is a reactive gas, and any type of reactive gas added to the weld when you're welding aluminum will cause some extreme contamination.
all right, great. James, any questions or chats? Anything coming in on the chat?
Yeah, we've got one here. Question of kind of the thin aluminum and how thin you can go with MIG. I think we're going to touch on that a little bit later, but maybe we can just briefly talk about kind of some of those limitations that we see with MIG on aluminum.
Yeah, sure. I mean, I'll start off and Chris can jump in, but for me, I kind of like to use a nice round number of about 100 thousandths. Is probably a starting point. You could go a little bit less, but the thinner you go, you really have to work on your technique now and your travel speeds, because aluminum is such a good thermal conductor. It heats up really fast. So if you're welding some thinner materials, you got to haul the mail. I mean, you got to arc and you're boogieing. So that 100 thousandths kind of gives you a little bit of kind of slush room there to kind of work the weld puddle and actually, you know, go at a manageable speed. So I would say I would start everybody off on, you know, pulse welding is a little bit different. You can get into some thinner materials with pulse, but for me, I tell most people it's right around 100 thousandths.
Right. All right, let's move on next to the MIG welding process. You know, obviously MIG welding, you don't have a torch, you're using a gun. You know, so a lot of questions is, you know, what gun can I use? You know, so just like anything else, there's a good, better, best scenario, and we'll run through those right now. So, so the first thing is that people will always ask me, can I use a MIG gun to feed aluminum or weld with aluminum? And basically my answer to them is, what's your tolerance of pain? Because not like steel wire, as you can see, aluminum wire, it's very soft. It's very hard to push through a gun. You know, the analogy I use with people is it's like pushing a wet noodle through a straw. You know, it's very, very difficult to do. So if you would want to use a MIG gun, you know, not saying you can't do it, but there's a couple things that you might want to take into consideration. So, you know, a standard MIG gun, you can see it's you know, that typical handle, and MIG machines, like on our 211, the gun is 12 feet long. So again, trying to push a wet noodle through a 12-foot straw, that's very difficult to do. But if you want to go and do it, the first thing that we would recommend doing is actually replacing the monocoil liner and use a plastic liner, or a Teflon liner, sometimes people call it. And what that does is it's a little smoother inside. It makes it a little bit easier for you to feed the aluminum wire through it. The other thing is if you go and you have a MIG gun set up with this Teflon liner or plastic liner, make sure that you only use it for aluminum. You do not want to go through that, because now by running steel through there, you're going to contaminate the inside of it. And you could also, you know, create some issues with you when you're welding aluminum for the next time. The other thing, when you're welding with MIG, you want to keep your MIG gun as straight as possible. That way it's going to give you the best chance of feeding the machine through, or the wire through the machine. And then the other thing is you're going to be using a MIG gun. There's some things that can help you out. Is that, use a larger diameter wire, because a larger wire is a little bit stiffer. And also there's a 4000 series and a 5000 series wire, which are your most typical wires. You got a 4043 or a 5356. A 5356 wire is a little bit stiffer. So if you want to use a MIG gun, use a larger diameter wire. And if so, use a 5000 series aluminum, because it's going to give you a better ability to feed it.
And there's also, there's another wire too that's kind of in between the two. It's 4943, and it has some little stronger strength profiles than 4043, but not quite as much as 5356. So that's kind of another option too.
Then the other thing that we want to do is inside of the machine. So if you're using a MIG gun to push aluminum, or later on when we talk about push-pull guns, you want to change your drive rolls. You want to use a U-groove drive roll. What a U-groove drive roll will do is actually it's like a saddle, and it'll gives the saddle more surface area to feed the aluminum through the liner. So it's going to give you better feedability. Also, a typical drive roll used for steel is a V-groove, and that V-groove will actually create some edges which could actually nick and cause your aluminum wire to flake off and eventually potentially plug up your liner. So again, if you're using a MIG gun or a push-pull gun, you want to use a V-groove drive roll. All right. So as far as the least expensive option, a MIG gun with a plastic liner, that's probably going to be your good application. Mm-hmm. As far as a better application, or what Miller recommends, for the smaller machines, is a spool gun. The reason we call it a spool gun is because you can see that right here we have a 4-inch spool of wire. This spool is actually part of the gun. So instead of feeding the aluminum wire through a 12-foot MIG gun, you're only pushing it through a 6-inch nozzle. So what that does is it gives you a better ability to feed the wire through the machine. So what we have is different types of spool guns that are available. The entry level one for the people who do occasional welding, we have like a Spoolmate 100 or a 150. And these are what they call a direct connect spool gun. And what I mean by direct connect spool gun is you can see here that on the back side of the spool gun, there's a connection very similar to that of a standard MIG gun. So if you want to switch between steel on your MIG gun to the spool gun, it's very simple to do. You just remove the MIG gun, put the spool gun inside, hook up your trigger connector, but then you also have to go to the back of the machine, change your gas from 75-25 over to 100% argon. So again, it's very simple to do. The disadvantage of it is if you want to switch between steel and aluminum, it takes some time to switch back and forth between the two guns or the two processes.
Yeah. One thing I like to add there too, Chris, is you're making sure you have the right consumables too. So a consumable like a contact tip for doing mild steel is going to be different in size than one for doing aluminum. So if you're welding 035 for mild steel, and then you're changing over to aluminum, the aluminum contact tip actually has a little bit bigger hole machined in it than the steel one, because the aluminum swells and so does the contact tip. There's a lot of heat generated there. So it needs that little extra room to feed the wire. Otherwise, it will seize against the wire and it'll pinch it and you'll start having burnbacks. So an 035 contact tip for aluminum is still actually a different size than an 035 for steel.
Very good. Yes. All right. Another spool gun option is for the people who are doing a little bit more welding for aluminum, or maybe in the light manufacturing or fabrication, where they are looking for a gun that has higher duty cycle and higher amperages. We have a gun called a Spoolmate 15A or a 30A that basically says these cables are like 15 feet long or 30 feet long. So it gives you a lot larger reach. These industrial guns also allow you to run a larger diameter wire. So, 047 or maybe even a 1/16 on higher some applications. Advantages of this gun is it's a little bit more expensive, but the nice thing is you can see on the bottom, there's actually the wire feed speed is actually on the bottom of the machine. So if you have to change your wire feed speed at the weld, you're 30 feet away from the machine. You don't have to go back to the machine to change your wire feed speed. You can just change it right here on the gun. The other nice feature this has is the trigger is the gas solenoid is actually a manual solenoid in the gun. So when you pull the trigger, you're actually activating the gas to, activate your argon. So the advantage of that is on these types of machines, you can leave your spool gun and your MIG gun hooked up at the same time. So the gas hose for this spool gun actually goes and hooks up right to your regulator on your argon bottle. So it makes it very simple if you're switching between MIG and aluminum. Just simply pull the trigger on the MIG gun. It's going to select your last parameters you're using when you're MIG welding. Steel. If you want to switch over to aluminum, you simply tap the trigger. It activates the argon, and it will recall the voltage and wire feed speed last time you were welding aluminum. So it makes it very simple to switch back and forth between the two processes.
Yeah. And its electrical connection point is actually a lug on a positive cable. So you're actually connecting it inside the machine near the wire drive housing instead of actually pulling the other gun out and installing the other one in. So that's the main reason it can still be hooked up at the same time as your regular MIG gun.
And then the last option is a push-pull gun. This again is the good, better, best. This is the best solution. This gun also costs a little bit more than your other two options, but this is for people who are, welding aluminum seriously, welding aluminum for a living. Okay. And what happens is what a push-pull gun is inside the handle of the gun right here, you can see there's actually a drive motor in here. So what this motor actually works is synchronized with the motor inside the welding machine. So what happens, the advantage there is instead of using a little 1-pound spool, you're able to use a 12-inch spool or a 16-pound spool. So what you're going to be able to do is spend more time welding versus changing out your spool of wire. All right, so you increase your productivity. The other neat thing about this is, these two motors are synchronized. So when we say push-pull, what that means is the motor inside the welding machine is pushing the wire through the 15-foot or 25-foot push-pull gun, and then the motor inside the handle of the gun is the one that's actually taking it and pushing it through the last 6 inches or through the head tube of the gun. So it's very beneficial because it actually is for people who are welding aluminum for a living, looking for productivity. The push-pull gun is the best option there. Now, when you're looking at machines to hook it up for, it's not compatible with the smaller, portable machines, but more advanced machines. Industrial machines are the ones that have the capability of the circuitry inside that to be able to be compatible with the push-pull gun. All right.
Awesome. Very cool. So maybe we should get into maybe a little bit of some troubleshooting. Like, I guess another big question I get from beginners is, why are some of my welds black? And for me, the first thing I tell them is start pushing the MIG gun instead of pulling it. So aluminum has an oxide layer on it, and that oxide layer needs to be burned away, which on a TIG machine, the AC does that. It helps chip that oxide off the aluminum so you can weld it. Well, we don't have that ability here, but we do have an extreme amount of arc energy because we're using the spray transfer mode. And what spray transfer means is once the wire comes out of the gun and hits the workpiece and starts, it's basically burning off before it even hits the workpiece anymore. So that arc energy is extremely high. And what that's doing is it's already burning that oxide layer off of the aluminum. But the forward motion of the gun is pushing those oxide layer away from your weld bead that you're already depositing behind it. If you're dragging the gun you're going to actually push those contaminants on your molten weld puddle. So that's going to create a lot of black soot. So that's probably the first one that I see. And Chris could probably demonstrate the push versus the pull right now, right?
Okay, what I'll do right now is I'll do the push technique. Again, the other thing when you're in a spray transfer, your contact tip to work distance needs to be a little bit further away than when you're doing short arc. So when you're short arc, typically your contact tip to work distance is maybe 3/8 of an inch. When you go to a spray transfer, you want to have a little bit longer stick out, maybe 5/8 to 3/4 of an inch.
So this first one, he's actually going to be doing a push technique. So you can see the gun angle. He's at about, anywhere from that 5 to 15 degrees is kind of optimal. If you get your push angle too severe, you're actually going to end up deflecting a lot of that molten aluminum off the plate. So you won't get enough penetration. So that's an excellent weld, Chris. So you could see Chris's technique on this one is he actually put a little puddle profile in there. And that puddle profile, it looks like almost like a little TIG weld. And that's different than a regular MIG machine where you're actually swirling the nozzle of the gun in like a E or a C pattern. He basically was just whipping the gun forward, but just dropping it towards the puddle briefly. Now, most beginners will start out with just pulling the trigger and then going with the MIG gun in a continuation. And then they'll start working on their technique after that.
All right. Show the drag technique, Andy?
the bad drag technique. All right.
Exactly. All right. Hang on.
And what you notice here, there's not a lot of sparks flying off of this, and that's your other indication you're in a really good spray transfer. It's not creating a lot of sparks at the arc. Yeah, so that one is totally soot contaminated. A good part of that would brush off with a stainless brush, but at the time, there is going to be some inclusion, obviously. Yeah, go ahead.
All right, we've got a question here. Can we discuss the out of position capabilities with and without pulse?
Fantastic. Yeah. So out of position in a spray transfer mode, which is kind of what we're in right now, is really not recommended. It's not recommended because, again, your puddle on time is constant. Whereas with a short circuit arc like regular mild steel, the arc is actually on and off, a couple hundred times a second. So you have that heating, melting, cooling of the weld puddle continuously happening. With spray transfer, that's not happening. It's always in a fluid arc on condition. So with pulse, what pulse does is it gives you some of the advantages of short circuit and the high arc transfer of spray. And now you can get some of that out of position back in play. So, like your vertical, still, me myself, when I'm doing out of position up, overhead, I still have a problem even with pulse. So I still don't have that quite down pat either. But I'm okay with the vertical. Definitely, if you can at all, if you can at all best possibility is do it in position or in the 1G position if you can. But pulse does add that versatility of out of position. There's no doubt. And the other thing pulse does add, and we mentioned it earlier, is you can drop down into more of the gauge material thicknesses. So I've done 18 gauge, no problem with pulse. Again, there is a little bit of technique and you still have to move along pretty good, but pulse with thin gauge material is possible. And actually that's what's recommended even with repairing some of the auto body and sheet metal stuff is, you're in a pulse mode. That's the factory recommendation in pulse MIG. And they're welding real thin gauge material also. That's a great question.
We've got one more here. Can you run aluminum out of an arc reach 12 with a Teflon liner off of an engine drive, specifically a Pipe Pro?
Well, it's going to be just in your straight CV. so I don't see why not. The arc reach feeder, again, that, like Chris said earlier, it's not a push-pull system, right? The arc reach isn't.
Right.
So you're having a regular, so you put the Teflon liner in it. James, if you bring up that picture of the MIG gun, I want to point out something that is important. The first one, there you go. If you notice the gooseneck on this one, it's at a very slight angle. And if Chris can hold up the MIG gun that comes with the machine, you're going to notice that there's quite a bit of a difference in the gooseneck angle. That is going to make it much more difficult. So if you do want the ability to have to push aluminum through your arc reach, my recommendation is to get the shortest gun possible. If you can get an 8 or 10-foot gun, and then get this the one with the smaller, much angle of the gooseneck. That's going to help alleviate some of those restrictions in the gooseneck, and your aluminum will also line up better with the contact tip. But that's a great question too.
Right, that gun right there is the gun that we provide in our auto body package. Again, what happens is these guys are using a larger diameter wire, 5,000 series wire, and they don't really need to go into trailers or anything like that. So you want to keep the cable length as short as possible. So like Andy said, that head tube you see there is a 30-degree head tube, which creates less drag, and again, gives you better results in feeding aluminum.
So I guess go back to some of our troubleshooting of our black welds. I would start with some of the basics too, is base metal prep. Make sure you stainless steel brush the joint areas first, typically remove some of those oxides, clean it with some acetone or some of that zero tri, which is kind of an acetone based product as well. But that will clean some of that off first. So that will eliminate some of that black sooty stuff. Another thing to keep in mind too is on the spool guns that Chris showed, the lower end models like the Spoolmate 100 and the 150, they're good starter units. But the other units, the more industrial ones, they also have better gas coverage, so they're not going to be nearly as sooty. Your tacks, when you first tack weld your stuff, you're also probably going to notice some slight soot there also, because you're in short circuiting that wire, and that's going to cause a little bit of soot at the tack. So I recommend tacking, wire brushing, and then welding. That might help you also, but make sure it's clean first. Obviously remove any parent metal or moisture. Another thing too, if you're not in a temperature controlled shop and the base metal is cold and you start welding on it and you create a lot of heat right away, you're going to start drawing some parent metal moisture. That's going to cause some contamination. I know they did a aluminum prep on Shop Talk. Let's see, it was like February 2nd, I think, right?
2nd.
Yeah, so you could also always go behind that Shop Talk presentation and review some of the base metal prep. But definitely, we talked about it earlier too, making sure you have the proper gas, 100% argon. And don't be surprised if you get a bottle of 100% argon and sometimes you'll get a contaminated bottle. Those bottles probably weren't 100% argon their whole entire life. And if they didn't pull a good enough purge on the bottles before they filled them, there could be some residual CO2 in some of those bottles. So that will cause not only some soot, but what the welding puddle, the puddle will look scummy. Like you're not just getting that shiny puddle anymore. It feels like the wire is just kind of digging into the base metal, and that's an indication of some contamination normally through gas.
Andy,
another thing, you could go back to that image of the weld. Something else I want to talk about, if you look on the right side of that image, that's where the arc ended, or the stop, or the crater. Something that aluminum you hear about is at the very end, that crater is actually below the surface of the face of the weld. So what happens is you'll see sometimes with aluminum, you'll have what they call crater cracking, just because let's say you're repairing a trailer, it's going down the road, it's flexing all the time. That vibration or that flexing, what happens is it could start in that dimple of that crater, it could start propagating back up through the weld and cracking the weld. So a practice that people will use, on some of the industrial machines, they have a crater feature. When you get to the end of the weld, you let go of the trigger, it'll automatically cool the puddle down and fill in that crater. But what you want to do if you're using a spool gun, a technique people use is to make a weld, stop, let the puddle cool, and solidify it, let it set up for a couple seconds, then pull the trigger and fill in that crater again. So that way that crater is at the same surface of what the face of the weld is.
Good point.
We have some questions coming in from the chat here. Two that are kind of tied together. One is, how effective are using aluminum blocks as heat sinks for welding thin aluminum? And the other one is, how do you preheat thick aluminum? So kind of on both ends of the spectrum, what are kind of some best practices?
For me, I like to just preheat aluminum in an old oven. So depending upon, what you're working on and how big it is, if you have the ability to put it in an oven, that's great. Some people just go ahead and use a torch, like an acetylene torch, but keep in mind that could contaminate the aluminum also. And so I've been in situations where I've had to just preheat. I've preheated with a turkey fryer before. So, I mean, you kind of have to do what you have to do, but my number one preheat would be an oven.
Right. Exactly. A lot of people will use a torch or a rosebud. Yes, it will do that in a pinch, but again, you could possibly be, contaminating your base material, which could, cause some, effects. It might not look right away, but below the surface, you could see some, pinholes or porosity.
Yeah, exactly. Yeah, porosity. Yeah. And so the thin material. So the other one was a heat sink, right? So yeah, aluminum would be a good heat sink, I guess, but at the same time, if you're welding thin material, and I'm just going to use 60 thousandths as an example. Let's say you're welding 1/16th, and you're using a backing plate of another piece of aluminum to try and heat sink that so you can MIG weld it. And I'm again assuming it's not pulse, but at the same time, you still have the opportunity to burn through that 1/16th, and then you're going to fuse it to that same base metals. So I would probably use something like a copper backing strip or something.
Ceramic backing copper bar. Yeah.
Yeah.
Another question that we've got here. I think you guys touched on it a little bit, but can we talk a little bit about arc starts? Kind of what to do at the start to avoid killing tips.
Chris mentioned a little bit of it early. Is some of it's your contact to work distance. So if you get too close and you just pull the trigger, and another thing is some machines have programming for aluminum. Now, means they're all designed basically around welding mild steel. They can kind of weld aluminum and they can kind of weld stainless. Aluminum is very soft, stainless is very hard, but they're really designed around the magnetics of the transformer and the stabilizer coil to weld mild steel. So when you start out, when you push the trigger and the wire comes down and hits the workpiece, the machine doesn't know you're welding aluminum and it just reaches a bunch of amperage to start burning off that wire. Well, with aluminum wire, it could be too much amperage and pop, there goes the tip. So, again, pull a little bit longer arc length and, your contact to work distance would be probably the first thing. Another thing would be too is obviously making sure you have the proper contact tips. I think we talked about that. There are some that are designed specifically for aluminum. But I guess the other thing is, the machine that Chris is using is the Miller 211. It actually has a program for aluminum, select aluminum, and it changes those volt amp curves, which means like how fast does it ramp up? How fast, what kind of inductance are you using to make the wire fluid? So those things are all changed electronically in that machine. The old machines couldn't do that. So much better machine today on the inverter machines because they actually have specific programs for aluminum.
also, it's very important cleaning the aluminum. So if you're starting on a dirty piece of aluminum oxide, again, that's an insulator, it's a barrier. Your wire might come down and buck and try to burn through that. And, eventually when it does touch the part, boom, it can burn back up into the tip.
One more quick question here. Do you need to have ultra high purity argon for your gas?
No, so UHP is like 99 and another like 99s after the decimal point. UHP isn't necessarily needed. And I've talked to quite a few customers, and a lot of them have gone to UHP because they had some experience with a contaminated bottle, and so they've got that notion because they struggled with what they thought was a standard argon bottle, which, to be honest, when you're TIG welding steel, sometimes you don't even notice that the bottle is contaminated. TIG steel is a little bit more lenient on that contamination level, but as soon as you start working with aluminum, yeah, it definitely shows its ugly face with a little bit of contamination. So UHP is not necessary.
Going back to the preheat question a little bit, what temps would we recommend for preheat? If you're going to preheat your aluminum at all, what do we kind of recommend as our starting point?
I mean, for MIG welding, it doesn't have to be that high. I mean, I get up to like 375, and then I'm usually pretty good for whatever stuff that I'm working on. I don't know, Chris, what do you think on?
Yeah,
Have you done anything higher? I
think that's, your typical range. Yeah.
Yeah.
Right. Anything else? All right. I think what we can do now is just move on to another topic. Is a lot of people will ask, what kind of machine do I need, or how big of a welding machine do I need? So as we had talked about earlier, to MIG weld aluminum, you need to be in a spray transfer. So our recommendation is to have a machine with 240 volt input, okay? Because power in is power out. So if you need more power to break into a spray transfer, you need more power into the machine so that it can take it and produce that output. Now there are some machines, and even on our 211, on 120 volts, there's direct connect spool guns. You can weld aluminum. And the thing is, you don't really break into a spray transfer. It's more of a short circuit transfer. So, on thinner gauge material, that might be all right. But if you're trying to do some structural welds or something with integrity to the weld, I wouldn't, recommend a 120 volt machine. We recommend going to a 240 volt machine. So, welding up to on a 240 volt or 240 machine like this 211, this one is, you can weld up to 3/8 material in a single pass on aluminum. So even, just breaking into that spray transfer, that's what you're looking for, but again, just to reiterate what we said earlier, once you're into the spray transfer, you can weld at the higher ends, but because you're in the spray transfer, you can't weld as thin as if you'd be into a more advanced, pulse type of machine.
Yeah.
Right.
Yeah, and one of the things too, I'm backstepping on you a little bit is, we talked a little bit about the wire alloys and the 4043 and the 5356 being the most common wire, which it is. 4943 is another good happy medium, but your 4000 series alloys will weld cleaner all than your 5000 series alloys of your filler metal. So even though they might be easier to push through the gun, the and bead appearance isn't going to be as nice with a 5000 series in MIG welding aluminum.
Yeah, the 4000 series has more silicon in it, so it gives you the shinier appearance, and also it lets the puddle flow a little bit more, wets out at the toes a little bit more. So, as far as the 4043 or the 4943 will give you, a better looking type of weld.
Yeah, and the 5000 has a little bit more magnesium and manganese in it, so that's going to give you that soot.
Gives you the black soot, and it sets up a little bit either, so at the toes of the weld, it might be doesn't flow or tie in as well at the toes. All right.
We got a question here in the chat. Will the Multimatic 220 with a Spoolmate 150 work okay for aluminum?
Oh yeah, do that quite often.
Yep, the Multimatic 220, or you said? So yeah, the 220, does have AC TIG in it, so, that is the nice feature for that product. But yes, as far as that product, you put it into DC, select MIG aluminum, the Spoolmate 100 or 150. Both of those guns would work just fine with the Multimatic 220 ACDs.
Yeah, I definitely recommend the 150 over the 100. It's a tick more money, but the contact tips are bigger and a little bit heavier. The barrel is also heavier duty than the 100, so it all around it is a better gun. And if you've ever seen any of our Real Garage series, our video series on Real Garage, I've done some projects with the Multimatic 220, some garage shop projects with it and the spool gun. So it does work quite nice.
We did have one that I've kind of saved. We had someone ask if we can kind of get a little bit more arc on, a little bit more arc shot, and try and see some of the technique that you're using there to get those, the definition in the puddle.
Oh yeah, that'd be cool.
Do that. Cool. Probably use a gloved hand. That's one thing about aluminum. You can't tell if it's warm. So, like I said, anytime you get around aluminum, have gloves on, have a welper on. It doesn't take long to inspect a piece of aluminum to see if it's hot. So,
when he's going along here, it'll look like he's hesitating briefly during the weld pass. But he's hesitating, and then he's just kind of like whipping the nose of the gun towards the puddle just briefly. So no circular motion. You don't want to get into the point where you're actually backstepping, because then again you're going to start sooting. So it's nothing like creating C's or inverted V's with a half twist. So.
All right, ready.
It's literally just a brief hesitation and a whip. And the reason you're kind of seeing the arc kind of go out a little bit is sometimes when you whip the gun down into the puddle, because the wire is feeding constantly out of the spool gun, it just creates a split second of like a short circuit, because you're actually driving the wire into the puddle for that little split second. So that's kind of why you looked like the welding arc was kind of going out briefly, but it's literally just because the wire just stubbed into the puddle for a second. Now do it vertical up.
We did have one more question here. Can we talk a little bit about alloys in regards to anodized materials, such as like tuna towers or things of that nature?
Yeah, so for anodizing, the 4000 series alloys aren't going to be, they don't anodize well. The color match isn't going to be the same. So if you want it to anodize properly, you want to use the 5000 series filler metals. Most of the people that do tuna tower repair, they'll use the 1000 series alloys, and they bring along a can of silver paint and they paint it out.
I think we've pretty much covered all of the questions that we've got here. Maybe one more. I currently have the Multimatic 200. Besides being able to TIG aluminum, how much better is the Multimatic 220? Is it worth the upgrade?
Yeah, as far as the upgrade, the neat thing about the Multimatic 220 is it has a capability that the MIG gun and the TIG torch can be hooked up at the same time. And when you switch from MIG to TIG, you do not have to go and change your cables around. So it's, again, it's kind of like I was talking with our spool guns and a MIG gun on some of the industrial machines where you just simply pull the trigger on the spool gun, or pull the trigger on the MIG gun, away you go. That's what you have on the 220 AC/DC. You have this quick technology. So if you're MIG welding, you pull the trigger on the MIG gun, boom, you start welding. The cables are hooked up properly for your electrode positive. Then when you go and you weld, pick up the TIG torch, there's two gas solenoids in the back of the machine that activate the solenoid that's hooked up to your argon bottle, and then you start welding with your TIG process. So, that is a really neat feature. The 220 with AC TIG over the current product that you have.
Yeah, and even in DC, like he mentioned, just the ability to do both. Like when I like put roll cages in cars and stuff like that, I'll take the MIG gun a lot of times and I'll just tack it in position and then pick up the TIG torch and continue welding. I don't even have to get out of the car and go back to the machine and reset the parameters because the machine remembers it. So I literally just, you know, bring the TIG torch and the MIG gun in the car at the same time. Another cool thing about it is it comes with the industrial foot pedal, that the same stuff that comes on our, high-end Dynasty TIG machine. So you get some pretty nice accessory pieces with it. And it's also compatible with the, yep, the wireless. So this is cool. I know it's just one less wire, but that one less wire is it's definitely a frustration eliminator.
Talking about pulsing on aluminum, when we talk thin, how thin is thin?
Gauge material, 18 gauge.
18 gauge, yeah.
Yep. I've gone a little less than that, but again, you have to work on technique. And you're moving faster. And the back side, I mean, I'll be honest, full disclosure, if you're doing 20 gauge and stuff like that with it, you're gonna dimple the backside of that piece a little bit, so it's not going to be perfectly flat and flush. You'll get a little bit of activation on the backside.
Is there an advantage of MIG aluminum over TIG aluminum and vice versa? Specifically, this guy has a Multimatic 220.
Yeah, I guess the advantage of MIG aluminum over TIG aluminum, I'll start with that, and then Andy, I'll let you talk about the advantages of TIG, is productivity. So, if you're building a trailer, the TIG process is a slower process. So if you're building a aluminum trailer or building a dock or repairing something where you have to put on a lot of feet of weld, the MIG process is better suited for that application.
Yeah, and all I gotta say is there's a reason they don't MIG weld the space shuttle together.
Right.
It's all about precision with TIG, right? You control your speed. You've got a foot control. It's very defined. When I come to the edge of the piece, I can feather off and control exactly how much heat is being put into it, and you don't have that with the MIG welding aluminum. And even in pulse MIG, in pulse MIG, yeah, it's better, but it's still not precise like TIG. So if you want precision, it's two different processes for a reason. And I'll even go to the Multimatic 200. It's a great machine. It's even a little bit more portable, and it's in a plastic case. It's more portable. It's designed maybe more for that MRO market or maintenance and repair organizations, and it's great for that. But I would say the Multimatic 200 is definitely a step up from that machine. And then you have your two different processes. I'm more of a TIG guy. I love TIG. But again, I'm not in that production environment and I'm just doing it for myself. So, but definitely when I'm going to be I'm planning on doing a MIG aluminum trailer project, and I'm going to be bothering Chris there to see if I can't steal one of his Miller Matic 255s, because they have an awesome pulse MIG machine. And I'm going to see if I can't run that thing.
You got it.
Got another question here. Kind of technique / process question. Welding lap joints of 1/8 inch aluminum squares that overlap 1/2 inch to 3/4 inch at the corners, and having trouble not burning through. Any tips?
And this is MIG,
Yes.
right? So it's
Yeah.
it's say that again. It's 1/8 inch square
1/8 inch
tubing.
aluminum squares that overlap at the
Oh,
corner. It's
just
a
aluminum.
lap joint.
Yeah. Oh, okay. Yeah. So it's just aluminum squares, not square tubing. Okay. Yeah. They're aluminum squares. I guess.
Obviously, you want to check if you position your part, if you're in a spray transfer, you have to move, but you want to definitely position your part so that the thicker gauge material is on the bottom, so you can direct your heat into your base material, and also gravity be working to help you, pull the heat or pull the arc or the puddle down to the, the thicker gauge material. That's, the one, suggestion that I would have for that. The other one would be is, if you have the capability of switching to pulse, the process, has a better control of the arc as far as where you're positioning it, and even shaping the arc as far as, the bead profile or of when, the process is happening. You can make it wider, you can make it a little bit narrower, so that would be, a process change, but, that pulse make would give you a little bit more control or ability to fine tune the arc.
Yeah, and if I understood is it both the same thickness material, but they're overlapped? Half inch to 3/4 of an inch, they're overlapped. And it's on a corner. So for me, I would weld from the outside edge to the corner point and then stop and let the thing cool a little bit. And then I turn the piece around so I could again weld from the outside edge to the corner. Trying to let some of that heat sink cool out of the piece. Unfortunately, that slows you up a little bit, but if you have multiple pieces to do and you can weld half of it each time and then come back the other half, that might help you from getting too much heat accumulated into the piece. Because you're only talking overlap of a 1/2 inch to 3/4 of an inch. That's going to build up a lot of heat right there.
Mm-hmm.
Looks like we've got most of these questions answered. So we'll talk a little bit about some of the upcoming Shop Talk Live episodes. So we've got a bunch of them kind of planned and in process. Our next Shop Talk Live will be focused on basic aluminum TIG. That one is scheduled for March 16th. And to keep track of that date, I just popped a link in the chat. When the registration for that stream is live, it'll be at that link. The other thing too, we had some people asking some questions about some more advanced MIG topics, and we will have an entire episode of this kind of dedicated to those advanced MIG topics. We'll talk a little bit about pulse MIG, maybe some process selection, a little bit more about push-pull guns, and maybe some specific, equipment selection pieces for more of the industrial applications like shipbuilding or trailer manufacturing.
Yeah, and we'll talk about different, like the terminology is even different. You got, arc control or arc length, and then it's not volts and amps anymore. It's just so yeah. So there's a little bit of terminology differences there, but yeah, and so I think it's just kind of getting into that curve of the parameters and what to adjust. And if you have a fully adjustable machine, there's a number of parameters to adjust to fine tune that pulse. So it is a lot more involved, and it is a session all on its own.
Yep. So like I said, that next Shop Talk Live is scheduled for March 16th. I think we've basically got it kind of covered here. Thanks everyone for kind of joining us tonight. Andy, Chris, thanks for hosting.
Yep. Thanks, everybody.
Thanks everybody for tuning in.
Guys, have a good one.